Okay, so we're gonna start our new unit, which is geometry. Of course, geometry follows trigonometry, right? Because part of geometry is the study of triangles as well, but we study other kind of shapes. So we study the 2D shapes, and then we also study the 3D shapes, which also includes the triangles, okay? So we're gonna see a little bit of trigonometry, or some of the trigonometry formulas in the geometry unit. So the first thing that we're going to do in this unit, we're going to talk quickly about the 2D shapes, okay? Finding the area of and perimeter of 2D shapes. We're going to look at composite shapes, so the shapes that are made of different shapes put together, and how can we find the area of that. Then we're going to move to the 3D shapes, okay? We're going to talk about the volume and the surface area of the 3D shapes, how can we find them? And then we're gonna do optimization. Okay, optimization is the most important part of this unit. Everything else you should be familiar with. Okay, the 2D and the 3D, finding the surface area and the volume and the perimeter, you should be familiar with these. Okay, and it's a matter of knowing which formula to use and plugging that number in. Okay. However, with the optimization, we go a little bit deeper, and we talk about which shape, if we're talking about rectangular prism, which shape would give me the maximum or the optimal surface area and volume. And with cylinders, which shape of the cylinder, how would the cylinder look like if I'm looking at the optimal, which is either the max or the min volume and surface area. This is very important for businesses. They look at this to decide on the shape, how high, how low, depending on what volume they want and how much material they want to use. Okay, so that's very important for that to learn this. Okay. The first thing, so at the end of this unit, we're going to do just an assignment. We're not going to do the 3D assignment this semester just because the 3D printer was giving me a lot of problem last semester and it wasn't working very well for most of the time. So we're going to just skip that. If you guys like to design something and you would like to learn how to design stuff, I can show you how to do it on Tinkercad, but we're not going to make it as an assignment. Okay, but if you're curious to learn, I can do that on the side. All right, it's just because it kept telling me heat error or whatever. Okay, and there's too many of you that we can't run it that many times. All right, any questions on what the unit is going to look like? All right, so you need that formula sheet, that purple formula sheet that I've given you. You need that with you all the time so you can refer back to it. So the first that we're going to look at is calculating the area of the 2D figures. All right, so that's where you're going to use the 2D side. All right, and then if you're going to look at the area of the circle, what's the formula for the area of a circle? So it's pi r squared. Okay, so it's as easy as plugging in the radius, right? And then finding it in the calculator. All right, when you're using this in the calculator, I want you to find your pi button and use your pi button. I don't want you to use 3.14. Okay, so you're going to find the pi button in the calculator, and then you're going to multiply it by 3 squared.
Sorry, so we'll have to find
the pi button. So you can't use the short version of the pi, which is the 3.14. You have to use the whole one. So if you can't find the pi button in the calculator, it's probably shift something, or it's shift this.
Okay.
Delete. So shift and then this. It's shift and then the EXP at the bottom. Okay. So usually when we find the volume or surface area or the area or the perimeter or whatever, we don't have a certain rule that we need to follow here. Unless I ask you to a specific one, you can round to 2 decimal place, that's fine. Okay, so for this one, what do you get for the answer? 28.27. Okay, if you can't find the pi button, make sure that you ask. All right, now I have to include a unit, right? Otherwise, your answer is not correct. So what would be the unit here? Yes, Shigbo.
No, no, I'm not.
Yeah,
The R is the radius of the circle.
that's
right?
correct.
And that's represented by 3 cm.
That's represented by 3. So remember that just as a recap from previous semesters or years or whatever, the radius is from the center of the circle all the way to the end of the circle. So that's called a radius. If you're looking for the whole line, it's called the diameter. Okay, so the radius is from the center to the edge of the circle to the end of the circle. Okay, so what will be my unit here? Centimeters what? Squared. Area has a unit of a square unit. Okay, all the time. So it depends on what your unit is for the radius. So it's centimeter, and then because I square the radius, right, it becomes centimeters squared. So areas always have a unit of square unit.
All areas or just circle?
All areas.
This is
Yeah,
private.
that's it. Just press it, and then do 3 squared. Put pi. You need to put multiplication, and then put 3 squared. Yep, and then press that button right here.
Thank you.
Are we okay with that? Moving triangle. So for the triangle, what's the formula for the area of a triangle?
Base into height
Base times height
or 2.
divided by 2. Okay, your height should be perpendicular to your base. Okay, so what represents the height here? The 7.8, and then your base is 12.8. So it depends on, eyes on me for a second. So let's say if I have this, and they gave me this here as my height, okay? This is my height, then therefore this is my base. The height and the base, they have to be perpendicular to each other. Okay? If we have a right angle triangle, which one would be your base and which one would be your height? The vertical is what? Your height. And this is your base, okay? So in a right angle triangle, it's already kind of, it's already giving you the height as your one of your legs, right? So don't get confused. It's already given to you in that sense. All right. So my base is 7.8, and then times 12.8 over 2. So what do you get for this? 49.92 centimeter squared. Perfect. knowing how to do the 2D shapes is going to help you to be able to find the volume and the surface area of the 3D shape, right? Because 3D shapes are composite of 2D shapes, right? So if I take a 3D shape, no matter what shape it is, and then I actually split it into pieces, it's going to be made of 2D shapes. So this is my cube here, right? If I open up my cube, it's made of squares, right? So knowing how to find the area of each square, and if I add them all up, that will be my surface area of my 3D shape, right? So this is the basic of the 3D. All right, so let's look at the third shape. What do we call that shape? It's a parallelogram. Okay, why is that parallelogram? Two lines are parallel, so this and this. So this one and this one are parallel to each other. And then this and this are parallel to each other, right? And they're not at 90 degrees. Otherwise, if they're at 90 degrees, that means they become a rectangle, right? In this case, it's a parallelogram. All right, so if I'm looking at my formula sheet, my parallelogram is the second formula, so it's base times the height, okay? So to find the area of that, so if you look at your formula sheet, the area is base times height, okay? Everything is given to me. That's beautiful here. So that's my base, that's my height. I just have to plug it in, and I have to find my answer. So this should be pretty straightforward and easy. 6.5? And your unit is? Meters squared. Okay? So you see that your sides are both in meters, so it's meters squared. What if one of the sides was given to you in centimeter and the other one was given to you in meter? You have to convert. Yeah. So you have to convert the units to the same unit. Doesn't matter which one, unless the question asks you specifically what unit you need to convert to, then it doesn't matter, right? If it doesn't tell you. Are we okay with this so far? So a composite shape is a complex figure that is made up of two or more simple figures. So first you need to cut the shape up into smaller, more simple shapes that we can find the area of, and then we then determine the area of each shape, and then add, or sometimes you have to subtract, depending on what kind of shape you have. Okay? So for example, if I have something that looks like this, right? That's a rectangle, right? I mean, I should have made it a little bit more deeper like this. That's a rectangle with half a circle taken out of it, right? So if you look, that half a circle is being cut out of the full rectangle, okay? So in this case, I have to find the area of the rectangle, I have to find the area of the semicircle, and I have to subtract, right? In order for me to be able to find the actual area of my composite figure, okay? Sometimes you have to add. So if you had the scenario where you have, for example, you have the rectangle, but also added to it half a circle, right? So again, you have the rectangle, you have to find the area of the rectangle, right? And then you have to add to it the area of the semicircle. So sometimes you add, sometimes you subtract. It depends on your scenario. All right.
Sorry, Mary.
Yeah.
So in this situation, if they give you this kind of stuff, you have to find the area of the rectangle,
Yeah, so you have to find the area of the rectangle,
then find the area of the semicircle,
find the area of the semicircle.
and subtract the semicircle from the rectangle.
In this case, you're going to add because you're adding it to it. Okay?
Add it together. Okay.
That's right. In the previous example where you had this, right? Because you're cutting out, so if you find the area of the whole rectangle, but then you take away this part of it because I'm cutting it out. So this is where I subtract. Are we okay with this? Okay. So you always find the best way. There's multiple ways. Like there's not only one answer in this. Sometimes you see the composite figure in a way. Sometimes I see it in a different way. It depends on each person and how they look at the shapes. I have this figure right here. This right outside, this is not part of the figure. Where is it? This is not part of the figure. Okay? So your figure is... Yeah, this is just giving you the height. So your figure is this, this, this. Okay? Multiple shapes. So what do you guys see? Okay, so let's look at this. So I have, so you want me to cut it this way? Yes. Okay, so you see this is one shape. Right? And then you see, I'm guessing this, right? That's shape number 2. And then a triangle, that's shape number 3. Okay? So you're seeing 3 shapes here. Okay? Are they added together? Yes. Yes, because they're put next to each other. All right, so I have to find the area of each. I know the area of square, or they don't have to be squares. The area of rectangle is length times width. Okay, so if I'm looking at length times width, that means I need this and I need this.
That's square,
So it's
right?
gonna be, no,
How do you know it's a square?
No, it's not square because if you subtract,
Subtract.
yeah, 13.4 from 6.2 is going to be 7.2. So
From 6.8. So try 13.4 minus 6.8. What does that give you?
no, it's not, it should be 16.
Sorry, yes, 6.2. Yeah, you're right.
7.2.
7.2. So you see that here, this line here, okay, is made up of 2 portions, right? This portion right here is equal to this portion, so that's 6.2, right? So this one is equal to this one, and that's equal 6.2. The whole thing is 13.4. So how much is left for this portion?
So you deduct 6.2 from 13.4.
So you have 13.4 minus 6.2, which is 7.2, right? So that means this is 7.2, and this is 6.8. So you see, it's not actually a square. Okay? It might look like one just because they're close, but it's not. And don't ever count on the drawing. Okay? Because people can draw shapes and they're not to scale. Okay? So don't count on it. Make sure that you can get your map done first. So length and width. So if I'm looking for area 1, so that's length times width, which is 6.8 times 7.2. Which is 48.96. And what's the unit here? Centimeter? Area. Area has a square. Yes? We can. We'll look at that later. Okay? So remind me to look at that after. All right? You see, that's method 1. There is a method 2 here. All right. So we found the area of 1. Now let's find the area of 2. Do I know both my length and my width for 2?
Yeah.
So what's my length? How about my width?
It's gonna be 6.1 plus 6.8.
Okay, one at a time. So 6.8 plus 3.1 makes this. So that's going to be 9.9. And the answer is 61.38. Again, that's centimeter squared. So I found 2 of the areas. I'm looking for the third one. For the third one, what do I need? It's a triangle. We know the base. What's the formula? Area is base times height divided by 2. So, my base is this, right? Where's my height? It's 12.6. It's given to me right here, but that's the same thing as going from here to here perpendicular, right? So that means this is the same thing as the 12.6. So I know both my base and my height. So that's 9.9 times 12.6 divided by 2. And the answer for this one is 62.37 centimeter squared. So my final answer for this should be an area total, right? Because I have to find all the areas added together. So my total area is the area of 1 plus the area of 2 plus the area of 3, which is 172.71 centimeter squared. So if you're looking at a problem like this, what did you see me or hear me or say or do when I'm standing here and I'm explaining this to you, or we're talking about this? And what did I write? What did you guys see me say, do, write? When I'm doing something like this. Did I just plug in stuff in the calculator and gave you the final answer? No. So what did I do? I explained, right? I showed you my work, because I can literally, if I want to, right? I can do it all in my calculator and just put the answer on the board and let you figure it out, right? Yeah. So for you guys, when I'm explaining this on the board, I'm not only explaining it for you to understand the question, but I'm also explaining it because this is how I want you to explain it to me. Because for me to know that you actually know the answer and you did not copy the answer, or you did not just guessed an answer, estimated, guesstimated, I need to know that you know what you're doing, okay? Because I can't mark whatever's in your brain. I can only mark whatever's on the paper, okay? So for me, I showed you the different so I shaped, right? I showed you. I wrote 1, 2, and 3. I showed you that, right? I wrote the formula, didn't I? Right? I'm expecting the formulas from you, so I know, right? You see that my solution is organized, right? When I say the area of 1, I know I can refer back to my picture, and I know that 1 is actually this shape, right? I need you to do the same thing. It helps you, right, while you're solving, but it also helps me when I'm marking your stuff, so I know that you know what you're doing. Does that make sense? You see that I included units, didn't you? Right? I didn't just put the units in my final answer. I put the units all along. Okay? Helps you keep track as well. All right? So when I'm explaining something to you here on the board, I want you to keep track of what I'm doing on the board. Okay? How am I solving this problem? Because I'm expecting the same thing in return from you. Okay? Because this is what I want you to learn from me, if anything. Because the questions are never going to be the same, right? Not here, not when you go to college, not in real life situation, but the process is going to be the same. Right? Any problem you solve, it's the same process. Okay? So if I'm looking at another way to solve this, okay, we're just gonna talk about the other way, and I'm gonna let you guys do it and see if we get the same answer. Okay? So how would you do this in another way? If you decide that you wanna, what other options do you see there? Okay, so we have a triangle. So the triangle, there's not a lot of options with that.
Then we have the 3.1.
So draw a horizontal line instead of a vertical line. Okay, so what shapes do you see here? So there's 3 shapes again. So you have 1, 2, and 3. Okay, so that's another way that you can cut your triangle or cut your shape. Okay, so take some time and solve that. How about, can you cut this in 4? Yeah, you can also cut this in 4, right? So you can have this as 1 and this here as another 1, right? So you can also do that. But it's one extra step, right? Which is not wrong, right? But it's an extra process.